Okay, so let's simplify this. We've got u double prime times, there's an x squared out here and there's an x, so that makes x cubed. So we've got x cubed times u double prime. Then we've got a 2u prime times x squared. But we have another u prime times x, so it makes a total of 3x squared u prime. And how many u's do we have? Well, we've got here an x times u, and here we've got a minus x times u. And those things cancel. And that is actually the heart of why this method works. The fact that whatever it is that multiplying u vanishes. Okay, so if you're working through an example problem and you find that it doesn't vanish at this point, then that signifies that you've made a mistake at some stage. So we don't have any u terms. What we have left is the 2x from the right hand side. Okay, so the u term has vanished. So now, although this still looks like a second order equation, it's got two derivatives, because there's no u term, really this is a first order equation for du by dx. So this is equation for u prime. Okay, so that's why the method is called reduction of order. We started with a second order equation for y, and we're now down to a first order equation for u prime. So let's give u prime its own name. Let's call b to be equal to u prime. And so our equation here is x cubed times v prime plus 3x squared times v is equal to 2x. Okay, our first order equation for v, which is u prime. Okay, we now have to solve that equation. All right, so there's two ways of solving this equation. The first thing you can do is say, well, it's a first order linear equation. There's a general method for solving all first order linear equations, which you can use in this case. What you do is you divide by x cubed. You get 3x squared over x here, which is going to be 3 over x. You integrate that, and you get the integrating factor, which is the exponential of the integral of this thing. That turns out to be the integral of 3 over x. That integral is 3 times log x. You take the exponential, you get x cubed. So it turns out that the integrating factor is precisely the x cubed that we divided by in the first place. So having gone through that process, we notice, well, yes, actually, it's when you look at that, you notice that here's x cubed. This function over here is 3x squared, which is precisely the derivative of x cubed. So what we'll do is we'll use the product rule in reverse. We'll say that this thing here is d by dx of x cubed times v. Okay? We can verify this is true by differentiating this product. So using the product rule, we take the derivative of x cubed, which is 3x squared times v, that's that term. And then we take the derivative of v times x cubed, so that is x cubed times v prime, which is that term. So these two things are exactly the same. And this is going to be equal to our right-hand side, which is 2x. Now, we have the derivative of something equals 2x. So we can work out what that something is by integrating. So we integrate both sides of that equation. On the left, we've got the derivative of something, and when we integrate that, you get that something back again. So it is x cubed times v is equal to the integral of 2x dx. By the way, there's something about my handwriting. Sometimes when I write an x, it comes out curly. Sometimes when I write an x, it comes out straight. They're the same. Okay, and the thing to remember about whenever you do an integral of this form, it's an indefinite integral, and we have to add in a constant of integration, and I'm going to call that constant c1. The reason is that we're going to get a second constant c2 in a moment. Okay, integral of 2x dx is something we can do. that's equal to x squared, and we have our constant c1. So now we have our an expression here, x cubed times v is this function, x squared plus c1. We can divide by x cubed now, and we can get what v is. So v is equal to x squared plus c1 divided by x cubed, which we can write as 1 over x plus c1 over x cubed. And there are those two x's creeping in again. Okay, so this is our v. So now, what were we trying to do? We were trying to solve that equation for y. Y we wrote as u times x, and u, well, u is related to v by v equals u prime. So to get u, we need to integrate v to get what u is. So let us do that. So we now have v, and we remember that v is related to u, v equals u prime, and that means that u is the integral of v dx plus a second constant of integration, c2. And I'm going to write this up here in the corner as well, so that we've got it out of the way. All right, we now have to do this integral. So this is the integral 1 over x plus c1 over x cubed, all integrated with respect to x, plus c2. The integral of 1 over x is log x, so that is log, in fact it's the log of absolute value of x. This, by the way, is the natural log. Some people write this as ln, some people write it as log, and there's an absolute value. So that's the integral of 1 over x. The integral of c1 over x cubed, well, we'll think of that as x to the power of minus 3. Integrate x to the n, you get x to the n plus 1 over n plus 1. Here n is minus 3, so this is c1 x to the minus 2 divided by minus 2. And then we have our c2 sticking out the back. So we can write that as log absolute value of x minus c1 over 2x squared plus c2. That's our u. And finally, we want to know what y is. Y is u times x. So y is u times x, and that is going to be x log x. We multiply this one by x, that gives us minus c1 over 2x plus x times c2. And we have the general solution of this problem. So just to summarize, we started with a linear second order equation with coefficients that were not constants, and we were told that one of the solutions of the homogeneous problem, that is the problem when we just eliminate the right hand side, was y equals x. We set y to be an unknown function times the function that we were told about. We substituted that into the equation we're trying to solve, and we ended up with a differential equation involving u double prime and u prime, but not u. We defined a new variable v, which was u prime, and we wrote down a first order linear equation for v. We solved that first order linear equation, so we got v. We integrate that solution, we get u. We multiply the u by the x that we were told about, and finally we get y, the general solution of this problem. And notice it has two constants in it, c1 and c2, which indeed any general solution of a second order problem should have. Thank you.